this is what I think of as an AI stack, right? Semiconductors, then on top of that, the clouds or the hyperscalers, on top of that, the foundation model companies. And even though a lot of the hype on AI has been on the technology layer, the biggest opportunities, almost by definition, has to be at the application layer, because we need the applications to generate even more revenue so that they can afford to pay the technology provider layers. So a lot of my focus is actually at the application layer, take advantage of these wonderful tools that we now have to build applications, but all the layers below are important too. And if were to look at the one most important trend in AI, I would say is Agentic AI or AI agents. And when I started to go around trying to give talks to convince people that agents is worth paying attention to a year and a half ago, I did not expect that around last summer, a bunch of marketers would get a hold of this term and almost slap this sticker on everything in sight, causing the hype to skyrocket. But let me share with you, maybe from a technical perspective, how I think about agentic workflows, right? So the way most of us use LLMs is by prompting it to generate a response, and that's a bit like asking a human, or in this case, asking an AI, to please type out an essay for me by writing from the first word to the last word in a linear fashion, all in one go without ever using backspace or even stopping to think first. And humans, we don't do our best writing like this, and nor does AI. But despite the constraint of being forced to write in this linear word after word way, AI does surprisingly well. Agentic workflows allows us to take a much more iterative approach, where we can ask the AI system to first write an essay outline and then do some web search if it needs, and take some web pages to paste it into the context and write the first draft, then see if some parts need revision and so on. And this iterative workflow allows the model to do some thinking, do some revision, do some more thinking. And by going around this loop many times, it takes longer, but it results in a much better work quality outputs. I think this multi-step workflow is at the heart of agentic systems today. And there's actually a lot of work that lies ahead of us to look at many of our business processes and figure out how to implement them into these automated agentic workflows. And if I were to take this picture of the AI stack, I'll actually update it as follows, where there's a new emerging agentic orchestration layer that makes it easier to build applications that make multiple calls to foundation models and clouds and other services. The good news is the agentic orchestration layer makes it even easier than before to build applications. And the conclusion that application layer has to still be where most of the value is, that's just, seems pretty clear to me. One interesting dynamic is whereas the switching cost for foundation models is very low, I actually architect a lot of my workflows to, deliberately make it easy to switch models. So when there's a new model, run evaluations or evals, and then switch models pretty much in 2 or 3 days if a new model is better. Switching costs for the agentic orchestration layer is much higher. And so this causes interesting new dynamics as well for the businesses building these offerings as well as the businesses using them. Happy to dive more into these in detail later if anyone's interested. And when preparing for this talk, I felt if were to pay attention to one tech trend, agentic AI is the one most important trend, but there's so much going on in AI. I want to touch on a few of the other trends I'm seeing that are really impacting many of our businesses, I think. And I actually had a list of 10 brainstorm trends, but cut it down to 5. What I thought would be 5 most important for this audience, which is coding assistance, fast prototyping, visual AI, voice stack, and data engineering. So I'm going to hit each of these relatively quickly. So even today, some people are advising others not to learn to code on the grounds AI will automate it. I think we'll look back on this as some of the worst career advice ever given. When coding became easier, like when we went from punch cards to keyboard and terminal, coding became easier, so more people went to code. When we went from assembly language to COBOL and higher level languages, that made coding easier. More people entered coding. By the way, I actually looked back, and found these papers people were writing when COBOL was being rolled out, and there were people that claimed, now we have COBOL, coding is so easy, we don't need programmers anymore. And then clearly the opposite happened. And with each step of the way, moving to IDEs, integrated development environments, to now AI-assisted coding, coding is becoming easier on every step, and that means more people should learn to code. And what I'm seeing is for professional engineers, this is already enabling a level of rapid engineering that is really quite unprecedented. And the dev tooling is one of the fastest changing sectors of AI. So with Anthropic, Google, OpenAI, others pouring massive resources into this, the dev tooling actually changes very rapidly. So GitHub Copilot is like, I think it was launched 2022, I think. Code autocomplete was a great thing. Then there was a windsurf cursor generation of tools, and then more recently, the even more highly agentic coding environments. Cloud Code came out like 2.5 weeks ago, I think, and I think that's actually fantastic. I personally use Cloud Code extensively, right? There's like a 2.5 with Cloud 4, sorry, which was launched about 2.5 weeks ago, 3 weeks ago, and I think the level of improvement of these tools, I'm fairly confident, will be frenetic. So for professional software engineers, this is already giving a massive boost to productivity. And then also for non-software engineers, I'm seeing that I think in the future, one of the most important skills of any knowledge worker will be the ability to tell a computer exactly what you want so it can do it for you. And I'm already seeing that for a lot of marketers, HR professionals, financial analysts, legal, those that know how to code are outperforming those that don't. And it doesn't mean they're writing the code themselves. It means they're steering AI to write the code for them. And maybe one experience I had that crystallized this for me was when I was working on the online course Generative AI for Everyone on Coursera. It was the fastest growing course on Coursera the year it launched. We had to generate background art like this using AI, using Midjourney. And I was working with a collaborator, Tommy Nelson, that understood art history. And what I found was because Tommy understood the language of art, he could prompt the Midjourney image generation system with the language of art, with the palette, the artistic inspiration, the genre. And so he could exert fine control over this to generate really nice artwork, which we wound up using. In contrast, I don't know art history. And so, I could prompt, like, please make pretty pictures of robots for me. And I could never demonstrate the control that Tommy could. And we wound up using all of Tommy's images. And so with telling a computer to do things for you as well, is the people that have that deeper layer of understanding of computers, they can give much more precise instructions to get a computer to do what you want. And I'm seeing that AI-assisted coding has lowered the bar enough that on my team, for example, I find that the marketers that know how to code can run much more interesting experiments, launch custom user feedback surveys, have custom email campaigns, and are increasingly starting to run circles around the ones that don't. See this true for more and more. So this will be exciting. Now, in terms of software development specifically, a lot of the work I do, I bucket into building quick and dirty prototypes to test an idea, and then also building, writing, production software or maintaining legacy software, right? So just as two rough buckets of the software work I end up doing. Depending on which analyst report you trust, it's been hard to find very rigorous studies. But writing production software or maintaining legacy code bases, maybe AI assistance is giving a 30 to 50% boost in productivity, right? Which is huge. This is great. But and I think the number is actually a little bit questionable to my mind still, but it is significant. But it turns out that for building prototypes, it's not a 30 to 50% productivity boost. It's more like 1,000% or 10x productivity boost, or maybe even. And there are a few reasons for this. It turns out that building prototypes or small standalone apps requires less integration with legacy software infrastructure. You also have much lower requirements if you're testing a new idea. So I know I'm not supposed to say this, but I routinely go to my team and say, go ahead and write insecure software. It doesn't bother me. Because if you are testing your software only on your own laptop and you have no intent of maliciously hacking your own laptop, it's okay to have insecure software running on your own laptop. And so I find that we have low reliability, security requirements, even usability requirements for quick and dirty prototyping. And this allows us, there are so many prototypes that I personally or some of my engineers will build literally in an afternoon that 2 years ago would have been 3 engineers in 6 months. And so the cost of software engineering is going down significantly. The cost of prototyping has plummeted. And what this means is to pursue innovations, is now economical to build tons of prototypes to see what works. In economics, we know if something becomes much cheaper, maybe we should buy a lot more of it. And so I know some organizations are feeling angst. A lot of proof of concepts don't make it to production. I actually have a different view. I think that if we can drive down the cost of building a proof of concept low enough, then if building 18 POCs that die a quick and cheap death is the price of finding the two that are really valuable, that's actually a fantastic trade-off. And so I know that move fast and break things got a bad rep in Silicon Valley because it broke things. Some people took this to mean you should not move fast. I instead tell my teams to move fast and be responsible. And I find that smart teams often have a lot of mechanisms to prototype, ship, test quickly, but in sandbox and safe environments that do not risk material downside to the business. I find that large businesses, we do have something to lose, right? We can't afford to have a single engineer build some crazy prototype and ship it and leak PII or damage our brand or hurt our revenue. We do have something to lose. So many businesses have protective mechanisms. Like before you ship something, you need privacy review, HR review, legal review, marketing review, compliance review. And then when you need 5 VPs to sign off before you can ship anything, everything grinds to a halt. But I find that if you can pre-allocate sandbox environments to let engineers run like crazy within that sandbox, because that limits the downside risk, then you can allow teams to innovate and build tons of prototypes to see what sticks, and only the ones that look promising, then invest in the security, reliability, and so on in the process of taking those to scale. So I think re-architecting businesses to take advantage of this has been. One of the reasons that we can build prototypes so much faster is because we have much better building blocks. So I find that what has happened over the last couple of years is the number of building blocks for AI has skyrocketed, meaning software tools that we can assemble together quickly to build compelling applications. One category of building blocks that I think is still not widely appreciated is visual AI. We've seen the text processing revolution take off, ChatGPT and so on, but visual processing, as opposed to just generation, but visual analysis is also working much better than before. And so with agentic workflows, given an image, a lot of visual AI takes this input and generates an output, like, this is a coffee mug. A lot of supervised learning. Input an image, tell me what this is. But it turns out that agentic vision lets us take an image and examine it, interpret it, go back to examine it, and by thinking for a little while, it takes a little bit longer, maybe a few seconds, but results in much better analysis of it. And it turns out the single most important and valuable type of image in our businesses is actually images of our PDF documents. It turns out that for actually, frankly, all of us on our laptops and our data warehouses, we have so many PDF documents that until recently were opaque to our algorithms because our software had no way to peer inside these documents, extract out the info, and get value from them. So one of my close friends, Dan Maloney, and I work closely together. And Dan and I have been thinking a lot about agentic document extraction, where actually, as an example, we can look at a medical form, extract the patient info, extract out the patient ID. And so all of these forms locked up in our data warehouses. Oh, here's an example. Reading a financial report. Let's see, extract out data from that image into tabular data numbers. That's, oh, I'm ready. Or here's a graph, and you can caption this graph to show, right, what's in this graph. And so I think we're actually seeing interest from many large businesses, nation states, with tons of documents that we can now, finally unlock the value of. Okay, so just kind of combining the building block of agentic doc extraction as well AI coding assistance, this is something that one of my engineers coded up in like less than half a day. But so one of the applications in a lot of businesses is invoice matching, right? So you have a database where have a list of expected invoices from Office Depot, Staples, Target, and so on. So Staples expecting approved a $65.50 account, but have an invoice. So a lot of common business process workflow, right? Gonna upload the invoice, match it. And so what I did was and this actually is a $120 invoice. So it doesn't match the expected amount. Uploaded it. So extracts out the fields and the data from the invoice, and then says that the extraction result has a mismatch because I was expecting $65, but instead, upload an invoice $120. So this is coded up in slightly less than half a day by one of my engineers using AI assistants with a building block of pulling information out of documents. And I'm finding that the adoption of this technology is one of the things that's just skyrocketing. So if in some of your businesses you have lots of PDF documents, you can now visually extract the information and get a lot of value out of it very quickly. All right, in addition to the visual AI, especially PDF files, I'm also very excited about the voice stack. So it turns out that building voice applications is much easier than it used to be a year ago. And maybe I'll skip this, but just to show a demo, this is an avatar of me talking. Oh, I'm not sure if it'll help me today. Can you hear this at all? Let me consider this for a moment. Attending an AI conference can be a great way to learn, especially if... Sorry, not sure if you heard that. Yeah. You heard it? Okay, a little bit? Okay. But I'll share with you. So it turns out that voice interactions are very natural for a lot of users. I know that starts off of a text revolution, but for a lot of use cases, if you give the user a giant text box, you're imposing writer's block on them. Because for a lot of things, they're hard to think about, hard to express. It's very difficult for users in some circumstances to write a thoughtful thing to give you input. Whereas with voice, many people feel much more comfortable just talking because we're used to talking to other people. Most users are better at talking than writing. Writing is a very difficult skill, right? Even for me. One of the biggest challenges of voice is this tension between the intelligence or the accuracy of the answer and the latency. Because for a lot of agentic workflows, when we built the avatar, we initially had a up to 9-second latency. And if you say something, a lot of human social dynamics cause you to expect a response quickly. If you need to wait 9 seconds for response, that's really difficult. But for a lot of business applications, you also want to give a thoughtful response. So if you build a customer service agent, you do not want it to casually say, oh, absolutely, I will give you a full refund, unless you've had time to match the business policy and you really, really want to do that. So in voice applications, there's a huge tension between latency, where user expectations are very high for low latency, versus the intelligence and the accuracy and the guardrails, where for high stakes, you don't say the wrong thing. But I find that there are technologies for resolving this. So one of the things my team uses is when you talk to a person, if I'm thinking, I'll stall for a time and say, oh, that's a good question. Or yeah, I could probably help you with that. And we as people naturally say those things while we're stalling for time to think to then generate the right answer. And so my team's actually built a lot of these technologies in order to get low latency and high accuracy. All right, last major trend is data engineering. So it turns out that many of our businesses have recognized the importance of data engineering for a long time, but a lot of our efforts were on structured data, right? The tables of numbers, Excel spreadsheets. But because of Gen AI, our ability to process unstructured data, text, images, video, audio, PDF files has gone up significantly. And so I'm seeing a lot of businesses re-architect the data, but now thinking much more about how to architect the unstructured data access. Because getting that data to AI for processing has a lot of value compared to 3 years ago when we didn't know how to process them. One trend that's making this easier is data gravity is decreasing. So data gravity refers to this idea that once you put data on one cloud, that will tend to attract other data and compute. It's just unthinkable to transfer a terabyte of data from one cloud to a different cloud for processing. We just don't do that. Too slow, too expensive. But Gen AI workloads is different. Round numbers, if you have a gigabyte of data, cloud transmission or cloud egress cost will be like 10 cents. But the cost of processing gigabyte data, even on a cheap model like GPT-4 Mini, is like $30 to $40. So because Gen AI is so processing intensive, the transmission costs almost don't matter anymore. And what this means is I'm completely fine transmitting my data halfway around the world for processing because it's so expensive to process it. And what this means is I'm seeing a lot more highly distributed software architectures where we have data packets kind of pinging all across the world to wherever is the best of breed service to be stitched together to orchestrate some very complex workflow. And so we're less bound, to one data center where I happen to put my workloads. And so also architecting the software to take advantage of this optionality. It turns out there are better LLMs released all the time. So many of my team's workloads are architected that when a new LLM shows up, we quickly run evals and then switch, right? Basically in 2 days to a new LLM if we like it better. And I think that orchestrating the workloads to take advantage of optionality because of the dynamism and the new building blocks and the new models, that's an important architectural design as well. So maybe just to wrap up, I think the summary of, in addition to agentic AI, I feel like these are what I felt are 5 very large trends impacting the work that we do. And maybe just to wrap up, I feel like with everything going on in AI, the set of application opportunities is just exploding. This is a wonderful time. Thank you very much.
You show digital avatar, but you were also talking about voice applications. Do you think that avatar part is important for the future of AI on how it will be perceived behaviorally by humans? So do we need that face of a human there?
Yeah, I think it's actually very application dependent. It turns out that at one end of the spectrum is this embodied glowing orb type of design, like Siri or OpenAI's chat and so on. And then there are also highly cartoonified, like an animal avatar, to cartoonified versions of people, to almost photorealistic human avatars. And I think we choose different things along the spectrum for different choices. I think the very human-like thing has more relationship value, maybe, which has good and sometimes ethical challenges as well. The cartoonified thing is less less distracting for some use cases, but also has less of that anthropomorphic relationship value, which is pros and cons. And then the cartoonified avatar, probably not for professional applications, for a lot of kids applications actually works well. The cartoonified human is actually an interesting design where there is a little bit of a relationship trust building mechanism, but also is no way anyone will mistake this for a human. So I find my teams choosing different appearances on the spectrum depending on the application skills.
Good to see you again, Andrew.
Thank you. Oh, yes. Good
How are you? Andrew, since you mentioned data engineering, one of the things that's still very elusive for most corporations is data quality, data fidelity. I haven't seen a lot of AI tools that really address that problem. This problem started 30 years ago, 40 years ago with data warehousing, and it still hasn't been solved. Have you seen anything new that could help corporations with that problem?
I don't know that I have any one magical solution. So I feel like it turns out, by the way, if you look at the foundation model training teams, the large training providers, something that is a large fraction of the efforts, but not talked about as widely, is data engineering. It's the usual data-centric AI stuff, right? So a lot of workflow of building LLMs is figure out where you're short, doing running evals, figure out where you're short, where do you need more data to augment it. Sometimes it's synthetically generated data, sometimes it's data from RL, sometimes just label traces, then figure out the data providers. It's actually that data loop is a much bigger, when I talk to multiple of my friends in multiple of the AI foundation model training companies, that a lot of the heads is, boy, how do I get the data to train my LLM? So it's actually that same workflow, all feels very familiar from the pre-Gen AI days of data-centric AI engineering. Maybe just to share with you some neat ideas. I think agentic data generation has been very interesting, where use an AI agent to think for a long time to generate data. and then this is used to train a model to try to do the same thing but much faster. So that's been exciting. One interesting thing I'm seeing, my team does this all the time now. It turns out that it used to be a pain to build data labeling tools. Now my teams agentically write data labeling tools. So when we have a new task, oh, let's build a new data labeler, no problem, because it's built by Gen AI. So those are maybe some new things I'm seeing. Yeah. Maybe some of the things. I have friends a lot of the data labeling companies. So it turns out that there's a lot of effort in reasoning traces right now. A lot of work on building reasoning models. A lot of work also on voice stack models. Actually, a lot of money is going to buying better voice data. This is one of the reasons I'm excited about the voice stack, because I know, because I've seen the roadmaps and so on, that there'll be much better voice models coming out over the next year from multiple businesses. So just kind of seeing where the trends are, where to bet on the tech stack now to where it's going. And then actually my team spends a lot of money on data for PDF files, and the adoption of PDF extraction that we see in Landing.ai is just going, it's definitely going like that right now.
Great talk, Andrew. I loved the different ways you've sliced it up. I had a question about the coding part. So I love the fact that you had a Vim screenshot. Up until a year ago, I was like hardcore Vim user. And now like 95% of my interactions happen through the chat window. And then like I'm reaching out for the code only 5% of the times. So I was curious to hear, where do you see this evolution go next? Sort of how many times would we be editing code versus kind of doing an end-to-end flow? Just curious to hear your thoughts.
Yeah, so I maybe just some thoughts, right? So I feel like one of the terms that's picked up is vibe coding, and I think unfortunately that's not a great way to think about it. So AI assisted coding is very important, massive productivity boost. The term vibe coding makes me feel like, oh, I'm going to go with the vibes and accept all the changes, but it's not like that, right? Coding with AI assistance is a deeply intellectual exercise, and after I do it for half a day or a day, frankly, I'm exhausted because it's very difficult and takes a high degree of thoughtfulness and skill to do this. So what I'm seeing is there's almost a new discipline of like rapid engineering. We can build stuff much faster than before. And I think as we go from the first versions of Copilot to the cursor windsurf generation to now the even more highly agentic coders like Claude Code and maybe OpenAI Codex, the degree of agency of these tools is increasing. But understanding the architecture that steered this is still very, and having a clear product sense, product requirement. I think AI product management, to have a clear sense of what is your product end goal that you want to get to, is still really difficult. I actually don't see massive product management boost. I know AI could do some design work faster, but thinking through what to build and why is still very difficult. But one other weird trend I want to mention is we've been used to thinking of the code as a very valuable artifact. It took my engineers so much time and effort to write the code. But one thing, for certain types of workloads, the code is no longer the valuable artifact, because I will build the code in half a day, and then next week I go, you know what? Let's just rewrite all the code from scratch using a different tech stack. So once upon a time, once we chose the tech stack, we were stuck, right? But now choosing a tech stack is still important, but for some applications, not all. There's some legacy software that's very hard to change, but for prototyping, code is no longer a valuable artifact. We just, let's re-architect it every week, right? Until a certain level of maturity, then it's no longer practical. Or let's redesign my database schema and have AI do the database migration for me. It doesn't bother me. I'm not doing the work. The AI is doing the work. So thinking through what are the stable parts of your work and what is no longer the sacred thing that you can't throw away every week, it has been a very interesting dynamic.